Good morning to all. This is Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. Today I am going to discuss about Gauss-Jordan method. So what is Gauss-Jordan method? By using this method, what we will find? So everything we have to discuss in this session. What is Gauss-Jordan method? So we will find the rank inverse of the matrix of order anything by using Gauss-Jordan method by using elementary transformations. So what is inverse of a matrix? Suppose A is any matrix. What is the inverse of A generally? We write A inverse. A inverse is nothing but inverse of matrix A. We have formula that is adjoint A by, we have A inverse equal to adjoint A by det A. By using adjoint A by det A, we'll find inverse of the matrix only of order 3 by 3. Now by using Gauss-Jordan method, we will find inverse of the matrix of any order, which is either square matrix or rectangular matrix or anything. By using some transformations, we will find inverse of the matrix. So what is Gauss-Jordan method and how we can find inverse of the matrix by using this method, and that we have to discuss in this session. So the inverse of a matrix by elementary transformations. Here we are using some elementary transformation to find inverse of A. So the method is nothing but here we call Gauss-Jordan method. What is the first step? Suppose A is a non-singular matrix of order n. Then we write capital A equal to In into A. A is the given matrix and we write A equal to some I into A. Any matrix multiply with identity matrix will get same matrix. So that's why I'm writing A equal to some I into A. Already we know I is nothing but identity matrix. If we multiply identity matrix into A matrix, we'll get same A matrix. So first step is whatever the given matrix A, write A equal to some I into A. A order is suppose 3. Then consider I also of order 3. So A equal to write I3 into A. That is prefactor of A. I am writing I before A. This I3 we call prefactor of A. What is the second step? Now apply elementary row operations only to the matrix capital A and in the left hand side, and also apply the same operation on prefactor of A. What is prefactor of A is here? I3. Apply the row operations here on left hand side A matrix and apply the same operations on the prefactor of A. The prefactor of A is here I3. Apply same operations on I3 also. In the right hand side, we will do this till we get this A become I, this I become some another matrix B. This A as it is. I am not changing anything in this matrix A. We apply row operations on left hand side A and apply the same row operations on right hand side prefactor of A. Right side prefactor is nothing but we have I3. So then I3 automatically change. I3 is nothing but we have identity matrix. That identity matrix change, then we'll get some another matrix B. Then we have if AB equal to BA equal to I, then we say B is the inverse of A. So here we can consider either AB equal to or BA equal to I. But we consider only one equation. That is, I am taking A equal to I3A, then definitely we get I equal to some BA. So if we want to take A equal to some I into A, then we'll A into I into A means we'll get B into A. If we take A equal to some A into I, apply column operations here. So if we take column operations on A, apply the same column operations on right hand side post factor of A. The post factor of A is here I. Then apply column operations on this I also. Then automatically I change, that matrix will get B and this A as it is, and this A changed to I. Then we have I equal to A into B. If either consider A equal to I3A or A equal to A into I. Choose any one equation. If we take A equal to I into A, we'll get I equal to BA form. If we take A equal to AI form, we'll get I equal to AB form. So I'm considering in this topic A equal to I into A. So I'm taking A equal to I3 of A. I'm considering prefactor of A only. If you take prefactor, apply only row operations. If you want to take postfactor of A is I, then apply only column transformations. If we take prefactor A, apply only here row transformations, rows. So like this, we have to change A into I, and after applying some transformation, this I3 change some another matrix B. This A as it is I am writing now, which is like I equal to BA form. Then definitely B is said to be inverse of A. Our intention is only to make the left hand side A is I and apply same operations on this prefactor of A. This I will change to B matrix. This B is said to be inverse of A. Then obviously B is the inverse of A. So now take the problem. Find the inverse of the matrix capital A using elementary transformations where A is 3 by 3 matrix order. Those elements are 1, 6, 4, 0, 2, 3, 0, 1, 2. This is the given matrix of order 3. So definitely we consider identity matrix order is 3. So I am writing A equal to I3A. Here I am taking prefactor of A is I. So A is nothing but given matrix, write as it is 1, 6, 4, 0, 2, 3, 0, 1, 2. And I3 is nothing but identity matrix. What is identity of 3 by 3? We have only diagonal entries and remaining all are having zeros. If suppose given matrix is order 2 by 2 means we consider only 2 by 2 identity matrix. Here the given matrix order is 3. That's why I am taking here 3 by 3 identity matrix. This is 3 by 3 identity matrix. That's why I am writing here I3. This A as it is. No need to write A here. We apply only row operations on prefactor of A on this RHS. This is RHS. Consider which is RHS and which is LHS. LHS we have A matrix. In the RHS we have only I3 identity matrix into A. This A as it is, right as it is A. Now what is our intention? Left hand side matrix A should be changed to I matrix by using only row transformations. Already what is identity matrix? We have to make only diagonals are ones and remaining all are make all the remaining all are zeros. So for that apply only row transformations. So applying R3, I want to change R3 row. How R3 row will change? 2 R3 minus R2 will get. Why I am taking 2 R3 minus R2? Anyway, the first two entries are zeros. I want to take this entry also become 0. That's why I am taking 2R3 minus R2. So that's why first row as it is and the second row also as it is. So 1, 6, 4 and second row is 0, 2, 3, that is also as it is. Last row I am changing. How R3 row change? Take 2R3 minus R2. 0, 0, 1. Our intention is only to get this is 0. That's why I am taking here 0, 1, 2. In place of 1, I am taking 0. By taking the operation 2R3 minus R2. Then we'll get R1, R2 as it is. R3 become 0, 0, 1. Now whatever the transformations apply on RHS, apply the same operations on right hand side also. Prefactor of A. So that is first row as it is, second row as it is. What is the third row? 2R3 minus R2 have to take here. So what is 2R3 minus R2? 2R3 minus R2. In the first place, 0. Both are zeros, that's why we'll get R3 0. Only R3 we have to change. R1, R2 as it is, and only R3 will change by taking 2R3 minus R2. And second entry, actually in I3 we have 0. If we take 2R3 minus R2, 2 into R3, 2 into 0 minus 1, we'll get here minus 1. And the next value, here already we have 1. 2R3 minus R2. So we'll get 2 into 1. 2 minus 0. We'll get here 2. So apply the row operations on left hand side. Similarly, apply the same operations on the identity matrix also. In the identity matrix, we have first two rows are as it is. We are changing only R3 row. So if we take 2R3 minus R2, the R3 elements are changed like this: 0, minus 1 and 2. This A as it is. Now go for the next step. What is the next step? Use the second row, second entry. Make this is 0. Our intention is take only diagonals and make the all are zeros. So that's why I'm taking R1 I want to change. R1 how change in place of 6 I want to take 0. So that's why I'm taking R1 minus 3R2. If we take R1 minus 3R2, R1 is 1 in place of R2. Here we have 0 only. That's why 1 as it is. And what is the next step? Here we have 6. R1 is 6 minus 3 into R2. 3 2s are 6. 6 minus 6 will get 0. That's why R1 change, that is 0. Using R2 change R1 elements zeros. So, and the next step is R1 minus 3R2. R1 is here 4 minus 3R2. 3 3s are 9. So, we'll get minus 5 in the third place. And the second row and the last row are as it is. I am not disturbing any R2 and R3 elements. Both right as it is. Now apply the same row operations on right hand side also. So R1 minus 3R2 I am taking. R1 is 1. 1 minus 0 will get 1. 0 minus 3 into 1 minus 3 I am writing here. And 0 and 0 will get here 0. And the second row and last row as it is. 0 1 0, 0 minus 1 2 I am writing as it is into A. Now for to get next step. What is the next step? Use the last diagonal. That is 1 only. Using this 1, make remaining 3 in place of minus 5. We want to take zeros. So that's why R1 I want to change. This is the R1 row. In place of minus 5, I want to 0 replace. That's why use R3 element, make this 5 0. So that's why I'm taking R1 plus 5 into R3. In R1 we have minus 5, R3 we have 1. How minus 5 will get 0? Minus 5 and plus 5. Then only we get minus 5 become 0. That's why I'm taking R1 plus 5 into R3. Minus 5 plus 5 into 1. 5. Minus 5 plus 5 will get 0. Then minus 5 becomes 0. And go for the second row. The second row having 3. How 3 becomes 0? Using 1. R2 I want to change. How R2 will change? R2 minus 3R3. R2 is 3 minus of 3 into 1. 3. So 3 minus 3 will get 0. So like this take the row operations. So to get minus 5 0, I am taking R1 is minus 5 plus 5 into R3. 5 ones are again 5. Minus 5 plus 5 will get 0. So similarly R2, in place of R2 we have 3. So 3 I want to make 0. How 3 will become 0? Using 1. 3 minus 3 will get 0. That's why multiplying R3 with 3 and take the subtraction. 3 minus 3 will get 0. And similarly apply the same operations on this right side also. So how R1 will change? R1 plus 5 R3. R1 is only 1. R3 there is no element. So that's why 1 as it is. I'm writing only right hand side matrix. So 1 as it is. R1 I'm changing. R1 plus 5R3 minus 3 minus 5. Here we'll get minus 8 and 0, and here plus 5 2s are 10. Then we'll get 10 here. Now R2 I want to change. What is the R2 operation here? R2 minus 3R3. 0 and 0 will get here 0 only. Next step, 1 minus 3 into R3. Already minus is there. Minus into minus plus. 1 plus 3 will get here 4. And next step, here we have 0. So 0 minus 2 3s are 6. So we'll get here minus 6. So R3 I am not disturbing. So write R3 as it is. 0 minus 1 2 into A. So right hand side matrix will get another matrix B, and the left hand side matrix will get 1 0 0, and the second row is 0 2 0, and last row is 0 0 1. So the final matrix will get 1 0 0 0 2 0 0 0 1 after applying R1 and R2 transformations. And right hand side change the matrix into 1 minus 8 10 0 4 minus 6 0 minus 1 2. This A as it is. So I am writing here 1 0 0 0 2 0 0 0 1, and right hand side matrix is 1 minus 8 10. Second row is 0 4 minus 6. Last row is 0 minus 1 2 into A. Now right hand side, what is our intention? Right hand side matrix should be, and the left hand side matrix should be identity matrix, which is not identity matrix. Why? Because in the second row, second entry is not equal to 1. We have to change that into 1. So by taking R2 by 2, that's why I'm taking R2 divided by 2. So if we take R2 divided by 2, first row as it is, I'm writing 1 0 0. Second row is 0. R2 by 2. Here we have only one entry, that is 2. That's why I'm taking R2 by 2. So if we take R2 by 2, we'll get 1 and 0, right, as it is 0. 0 by something we get only 0. And last one already here we have 1. So write 0 0 1. Now go for the right hand side. So here the application is R2 by 2. Now change only R2 row by taking R2 by 2. So that's why first row I am writing as it is 1 minus 8 10. Second row is here 0 4 minus 6. But second row we have to change. How second row will become change? By 2. Take R2 by 2. 0 by 2 we get 0. 4 by 2 will get 2. Minus 6 by 2. 2 3s are. So we'll get minus 3. And the last row is as it is 0 minus 1 2. So only R2 change, R1 and R3 are same. Whatever the transformation apply on LHS, apply the same row operations on this prefactor of A. That is on identity also, identity matrix. So that's why we'll get 0 minus 1 2. Then which is like I3 equal to B into A matrix. This is another matrix. First we took identity matrix on right hand side. After taking the transformations and apply the transformations on prefactor of A, this A become I, this I become some another matrix B. Then we say AB equal to BA equal to I, then B is said to be inverse of A. Then obviously B is the inverse of A. By using Gauss-Jordan method, what is the Gauss-Jordan method? Applying only transformations. Apply the transformation, those are only row transformations. We can use column transformations also. For what equation we can use column transformation? If we take A equal to some A into I. If we consider post factor of A, I, then we can take column operations. Then the resulting matrix or resulting equation will get I equal to A into some B. Apply here only column transformations. If we take A equal to some I into A, prefactor of A, then we apply only row transformations. So if we apply row transformations on A, apply the same operations on this prefactor of A, then we'll get A is become I become A. This is another matrix B. This B is said to be inverse of A. Generally, what is the inverse of A? If A is the given matrix, if we take another matrix B, multiply A into B, that another matrix, then definitely we'll get the product is identity matrix. If we get the identity matrix by taking B another matrix, then B is said to be inverse of A. This is the definition of inverse. Now here using transformations we are finding inverse of given matrix A. If you want to take BA equal to I, then take the equation. First write the equation of the form A equal to A into I. Whatever the A matrix order, write the identity matrix of same order. If A is 4 by 4 order matrix, then write A equal to A into I4 also. Sometimes you will get A into this A will change I. This I4 sometimes you will get I2 or sometimes you will get I3 also. But based on that, this I4 will change. This I4 is another matrix. This B is said to be inverse of A. Apply column transformations. So at a time we cannot use both rows and column. Take any one of these equation. If we take A equal to AI, or if we take A equal to I into A, for this use only row transformations, and if we want to take A equal to AI, apply only column transformations on this equation. Then we'll get inverse of the matrix. Then we'll get the matrix of the form finally I3 equal to BA form. This B is the unknown matrix. This we don't know starting. So our intention is only to make left hand side A should change to I. Then I equal to B, I mean by the definition we say B is the inverse of A matrix. Hope you are all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.